Download this code from codegive.com, link in the description below. Deep dive into Android file management, folder deletion with code examples. This tutorial provides a comprehensive guide to deleting folders in Android using code. We'll cover everything from basic file I/O principles to robust error handling and permission management. We'll also address common pitfalls and best practices to ensure your file deletion operations are safe and efficient. Understanding Android file systems and permissions. Before diving into code, it's crucial to understand the Android file system and the associated permissions. Android restricts direct file access to protect user data and system integrity. Internal storage. This is a private storage area for your app. Files stored here are accessible only to your application and are automatically deleted when the application is uninstalled. You don't typically need special permissions to access files in your internal storage. External storage. This can be removable storage, like an SD card, or a dedicated partition on the device. It's accessible by other apps and the user, through a file explorer. Accessing external storage requires appropriate permissions. Scoped storage, Android 10 and above. With Android 10, API level 29, and above, scoped storage provides more granular control over how apps access external storage. Apps can only access specific directories without explicit user permission. There are exceptions. Media Store APIs. Use Media Store APIs for accessing media files, images, videos, audio, located in shared storage like the downloads, pictures, videos, and audio directories. Storage Access Framework, SAF. The user grants your app access to specific files or directories using a system UI picker. Legacy access. You can request Android request legacy external storage equals true in your Android manifest.xml. This allows access similar to pre-Android 10, but it's strongly discouraged and will likely be removed in future Android versions. Use it only as a temporary solution while migrating to scoped storage. 2. Permissions required for folder deletion. The permissions you need depend on the location of the folder you want to delete. Deleting files within your internal storage. No special permissions are needed. Deleting files within your app's specific directory in external storage, pre-scoped storage or with legacy access. You'll need the right_external_storage permission in your Android manifest.xml. However, as mentioned above, you should aim to avoid using this permission if possible and migrate to scoped storage. Deleting files within user-selected directories. Using SAF you will not request permissions in the manifest file. Instead, you will obtain the URI using action_open_document_tree intent and use the document file API. Deleting media files with media store. You don't request right_external_storage. The system handles the permission through the media store API, prompting the user if necessary. 3. Code examples, deleting folders in different scenarios. Let's explore code examples for different scenarios. Deleting a folder in internal storage. This is the simplest case. Explanation. 1. Delete internal storage folder, string folder name, context. Takes the folder name and the application context as input. Creates a file object representing the directory within the internal storage. Context.getFilesDir, returns the path to the app's internal storage directory. Calls the delete recursive function to handle the actual deletion process. 2. Delete recursive, file or directory, This is a recursive function that handles the deletion of a file or directory and its contents. Base case *, if the file or directory is a file, not a directory, it attempts to delete it using file or directory.delete. Recursive step asterisk if the file or directory is a directory, it iterates through its contents, files and subdirectories. For each child element, it recursively calls delete recursive to delete that child. This ensures that all files and subdirectories within the folder are deleted before the main folder is deleted. Error handling asterisk if any deletion fails, example due to permissions or file in use, the function immediately returns false, indicating that the deletion process was unsuccessful. Directory deletion asterisk after all children are successfully deleted, if any, the function attempts to delete the directory itself using file or directory.delete. 3 example usage asterisk shows how to call the delete internal storage folder function from an activity or fragment, passing the folder name and the context. Includes logging to indicate whether the deletion was successful or not. Important considerations for internal storage deletion asterisk. Asterisk application context asterisk always use the correct context, example the activities context or the application context, to access the internal storage directory correctly. Asterisk error handling asterisk the delete recursive function includes basic error handling by returning false if any deletion fails. You can extend this to provide more detailed error information, example by logging the specific file that failed to delete. Asterisk file locking asterisk if a file is currently open or being used by another part of your application, the deletion might fail. Make sure to close any open file streams before attempting to delete the file. B. Deleting a folder in external storage, pre-scoped storage or with legacy access, discouraged. Android manifest.xml, add this permission, but try to avoid it. Java code asterisk. Explanation asterisk. 1. Android manifest.xml asterisk the right underscore external underscore storage permission is declared in your manifest. 2. Delete external storage folder, string folder name, activity asterisk. Checks if the right underscore external underscore storage permission is granted using context compat.check self permission. If the permission is not granted, it requests the permission using activity compat.request permissions. If the permission is granted, or after the user grants it, it creates a file object representing the directory on external storage, using environment.getExternal storage directory. Calls the delete recursive function to handle the deletion. 3. On request permissions result, int request code, string permissions, int grant results, asterisk. This callback is invoked after the user responds to the permission request. It checks if the request code matches permission underscore request underscore code to ensure it's the result of the permission request initiated by the delete external storage folder function. If the permission is granted, grant results 0 == package manager.permission underscore granted, it calls delete external storage folder again to proceed with the deletion. 4. Delete recursive, file or directory, asterisk the same recursive deletion function as in the internal storage example. Important considerations for external storage deletion, pre-scoped storage. Asterisk permissions asterisk always request the right underscore external underscore storage permission at runtime if you need to delete files on external storage. Handle the permission request result in on request permissions result. Asterisk scoped storage asterisk this example is for older Android versions or for apps using legacy access. Modern apps should use scoped storage and avoid requesting right underscore external underscore storage. Asterisk environment.getExternal storage directory, asterisk this method is deprecated in API level 29, Android 10. Avoid using it in new apps. See deleting folders using Storage Access Framework, SAF, preferred approach for Android 10 Plus. This is the recommended approach for interacting with files on external storage in Android 10 and later. SAF allows the user to select specific directories, granting your app access to those directories without requiring broad storage permissions. Explanation *. 1. Select directory to delete, *. Creates an intent with action _open document _tree to prompt the user to select a directory. Starts the activity for result, using pick _directory _request _code to identify the result. 2. On activity result, int request code, int result code, at nullable intent data, *. This method is called when the user returns from the directory selection activity. It checks if the request code matches pick _directory _request _code and if the result is activity.result _OK. If the result is successful, it retrieves the URI representing the selected directory from the intent data. Calls delete directory using SAF to start the deletion process. 3. Delete directory using SAF, URI tree URI, *. Creates a document file object from the URI using document_file.fromTree URI. Document file is a class provided by the Android.document file library that provides a consistent API for interacting with documents, regardless of their location, local file system, cloud storage, etc. Checks if the document file represents a directory using pickdir.is directory. Calls delete recursive SAF to handle the recursive deletion. 4. Delete recursive SAF, document file directory, *. Recursively deletes files and subdirectories within the selected directory using document file methods. Uses directory.list files, to get an array of document file objects representing the files and subdirectories within the current directory. Iterates through the files and subdirectories, recursively calling delete recursive SAF for subdirectories. Deletes files using file.delete, and directories using directory.delete. Includes error handling using try-catch to catch exceptions that might occur during the deletion process. Key improvements in SAF deletion *. No manifest permissions *. You don't need to request write _external _storage in the manifest. User control *. The user explicitly grants your app access to the selected directory, respecting their privacy. Consistent API *. Document file provides a consistent API for interacting with documents, regardless of their storage location. Scoped storage compliance *. This approach aligns with the principles of scoped storage, minimizing your app's need for broad storage access. How to use the SAF code *. 1. Add the Android.document file dependency to your build.gradle file *. 2. Create an instance of the SAF file deletion class in your activity or fragment. 3. Call the select directory to delete method when you want to start the directory selection process. 4. Override the onActivity result method in your activity or fragment to handle the result of the directory selection activity. Deleting media files using media store, another scoped storage method. This method is the preferred way to delete media files, images, videos, audio, on Android 10 and above. It leverages the media store APIs for accessing and manipulating media files. You don't need write _external storage. Explanation *. 1. Delete media file, long file ID, string MIME type, *. Takes the file ID, a unique identifier for the media file in the media store database, and the MIME type, example image/JPEG, video/MP4, as input. Determines the appropriate content URI based on the MIME type. Mediastore.images.media.external_content_URI for images. mediastore.video.media.external_content_URI for videos. mediastore.audio.media.external_content_URI for audio files. Creates an item URI by appending the file ID to the content URI using content URIs.with appended ID. This creates a URI that specifically identifies the media file to be deleted. Calls resolver.delete, item URI, null, null, to delete the media file. Handles security exception. This exception can occur if your app doesn't have the necessary permissions to delete the file. In this case, you may need to use action_open_document or action_open_document_tree to request the necessary permissions from the user. Handles other exceptions that might occur during the deletion process. How to use this media store code *. 1. Create an instance of media store file deletion in your activity or fragment. 2. Call delete media file, with the file ID and MIME type of the media file you want to delete. Important considerations for media store deletion *. File ID *. You need to know the file ID of the media file you want to delete. You can obtain this ID by querying the media store database. *MIME type *. The correct MIME type is essential for determining the correct content URI. Security exception *. Be prepared to handle security exception, as it might indicate that the user needs to grant your app permission to delete the file. 4. Robust error handling and best practices. Try-catch blocks wrap file I/O operations within try-catch blocks to handle potential exceptions like I/O exception, file not found exception, security exception, and illegal argument exception. Logging use log.d and log.e to log debugging information and errors. This can be invaluable when troubleshooting file deletion issues. Resource management close file streams and other resources in finally blocks to ensure they are properly released, even if an exception occurs. This is less applicable to directory deletion, but crucial when working with files you are reading or writing. Background threads perform file deletion operations on a background thread, using async task, intent service, executor, or coroutines, to avoid blocking the main thread and causing ANRs, application not responding. User feedback provide clear feedback to the user about the status of the file deletion operation, example using a toast, snack bar, or progress dialog. Empty directory check before attempting to delete a directory, check if it's empty. Deleting non-empty directories can lead to unexpected behavior. The recursive functions in the examples already handle this. Permission checks always check for the necessary permissions before attempting to delete files on external storage. Scoped storage adoption prioritize adopting scoped storage. Avoid relying on write_external_storage unless absolutely necessary. Use SAF or Media Store APIs instead. Content Observer consider using a Content Observer to monitor changes to the Media Store database. This can help you keep your app's UI synchronized with changes to media files. File name sanitization if you are allowing the user to specify the folder name, sanitize the input to prevent directory traversal attacks, example prevent users from using to access parent directories. V. Complete example, SAF plus background thread. This example combines SAF with a background thread using async task to perform the deletion. Key improvements in the complete example asterisk async task for background processing the delete directory task class extends async task to perform the directory deletion operation on a background thread. This prevents the UI from freezing during the deletion process. UI feedback the on pre-execute and on post-execute methods of async task are used to provide UI feedback to the user, such as displaying a deleting directory. Toast message before the deletion starts and a success/failure message after the deletion is complete. URI persistence the get content resolver, take persistable URI permission, method in onActivity result, persists permission to access the selected directory even after the app is restarted. Clear selected URI the selected directory URI is cleared after successful deletion. 6. Conclusion. Deleting folders in Android requires careful consideration of file system permissions, error handling, and best practices for asynchronous operations. This tutorial has provided a detailed guide to deleting folders in different scenarios, including using internal storage, external storage, with legacy access, storage access framework, SAF, and media store APIs. By following the recommendations in this tutorial, you can ensure that your file deletion operations are safe, efficient, and compliant with Android's scoped storage guidelines. Remember to prioritize scoped storage, avoid requesting broad storage permissions whenever possible, and always handle potential errors gracefully.